Okay, maybe I think we should start now. First, thank you everyone for joining us today for this webinar. Why 3D printing is important to STEM education and how we build talents for the future. So a little bit of housekeeping. So in your Zoom toolbar, maybe in the bottom or at the top of the screen, there's a button that's the Q&A, which is you can type in any questions you have during the webinar. Our colleague might reply you immediately, or if your question is for the presenter or panelist, we will answer that at the end of the webinar. So also there's a raise hand button. So during the webinar, we may ask you a question, yes or no questions. So you can raise your hand, yes. All right, so it's very easy. So let's get into it. Okay. Let me just quickly share again. Sorry about. All right. Yeah. So today's presenter, that's me, Alan Yu. I'm a Markforged application engineering manager, and then we're very happy today. We have a colleague from Western Sydney University, we have a Professor Richard Yang, Associate Dean, researcher in School of Engineering, and then we also have Dr. Tosin, Technical Manager in Construction, Civil, and Engineering Tester. And we also have Mr. Raju Maji, Senior Technical Officer in the Advanced Manufacturing Center. So let's get into it. So education, a school, a university has a lot of function. One of the function is to fill the gap of the society about the talents that we need in the future. So according to some research from US, North America, actually there will be 2.4 million positions in manufacturing that won't be filled in the next couple of years. And 3D printing is one of the advanced manufacturing technology today, and there's a lot of benefits and also a lot of a challenge. One of the challenges, according to McKinsey and company research, is actually we lack of talents able to use the technology, lack of the knowledge about design change and how to utilize the technology, and some of the standard, the material testing that also require a lot of cooperation between education industry and the commercial world. So every country has to be prepared, but always comes to the challenge about like advanced manufacturing, right? And especially today, there's some of the misconception in the new generation. So engineering and manufacturing is very important, but always perceived as like a low tech, low income, boring, dangerous career. Probably because of their parents, which come from baby boomer in that time. It might be true, right? So according to the experience, manufacturing might be like a dangerous, low income, and repetitive job. And also recent years, there's a hype of the software, IT, finance area, attract a lot of young people to join that sector. And also the trend of like shared economy, freelancing, and casual working. That is also like reduce people want to dedicate a very long time in the manufacturing world, because you do need to gain a lot of experience and time to understand the manufacturing industry. So the new generation, new graduate also not ready. So the training of a STEM skill wasn't enough previously, and the skill set also shift right from really repetitive job to more advanced design and manufacturing process skill set. So also there's too many things to teach, right? So what are the essential skills to teach? Probably we can just like teach a little bit of the basic of all the different technology, which it means is not actually enough to actually get a very good career or job once they graduate. And also job is created faster than the speed that we can train today. And teachers are normally very busy doing many other things, less time to focus in more in-depth knowledge training. So learning is also kind of restricted because of the safety. So recent year we also keep talking about safety for the students, and a lot of equipment from industrial world is kind of more sophisticated, which need practice. So in order to spend time to that, probably we don't let them to use it, right? Rather than that, like technical people or teachers to demonstrate, rather than to let the students to actually have a hands-on experience. So, and also it's changing very fast in the real world, right? Every couple of years, there's a new technology, new hype. So it's kind of difficult to catch up as well. Also, the sophisticated technology is kind of not that easy, right? At the beginning to learn. Training the basics is okay, but like getting more knowledge, which take a very long time. And the practical skills used in the industry. Normally we require some certification and formal training, which is also probably might be not ready in the school as well. So today we'll talk about that. First is the advanced manufacturing lab, or 3D printing is becoming one of the hot topic now, right, in all the education industry, university, institute. So we'll talk about that. And then very happy today we will have residents in the university to share their experience in their manufacturing center to talk about all these, how to build the talent for the future, how they work with the commercial world for research project, and all the experience that they gain during the process. At the end, we will spend a little bit of time to talk about Markforged as a company, why Markforged is a good technology to invest in general. So over here, there's a lot of hype about everything, but STEM or STEAM education is definitely becoming one of the core in education industry today. So STEM education, actually, if you look at all the news, trend, so every different country is spending a lot of money to bring their school, university up to the standard. They're investing a lot of money, not just the hardware, but also software to upskill the teachers, facility, and all the things that they need to prepare the new generation for the future world. So Phoenix Center is a kind of a must to have now today in university and institute. So one of the example we have in North America is Rochester Institute of Technology. So they're in upstate New York. They're actually a third largest producer of STEM graduates degree among all the private universities in the US. So the students coming out of here are at a great advantage with the practical hands-on experience. So they get on the machine, so they can find job easier, and they can dive into the actual world, the actual experience. So who use all the printers in RRT? So basically all the students in the 3D printing class, master PhD students. Also, they support their clubs and on the campus for different projects, competition, and interesting things. They also work with a local business and federal agency for research and kind of a project for advanced product manufacturing. And then we also have 3 different centers in Europe: Print City, Additive X, and Oslo-Map. So they're both Print City and Additive X is from UK, Oslo-Map is from Norway. So 3D Printing Center is actually not that new, right? Like a couple of years ago, there's already a wave of building 3D Printing Center or additive manufacturing center. But at that time, it's more focused in researching material characterization, standardization, to work with early adapter, which is a small amount compared to the whole manufacturing world. In the education side, it's more to have doing like simple prototyping, right, with a low cost. So actually, we can spend that money for students to do some of the projects, simple projects, or some ad hoc specialized training. But today, actually, for those centers now in here, they focus more in driving small, medium enterprise adoption. They outreach to the industry and commercial world to bridge that with the education, make sure the student came out of the university already understand how the actual world work, and they will have the skill set to create a career in manufacturing industry. So this is some of the example, right? So basically unlocking the potential of medical computing in education. They have like one platform for many application or job using Markforged platform. Student can pretty much make anything they want by themselves because it's a safe and easy to use technology. So they have that freedom to create, to explore their creativity. So the student coming out of this university great advantage with practical hands-on skill, and the student success during the attendance and after graduation. So successful implementation of the additive manufacturing technology to the industrial level, right? So actually, it's not just basic, simple to teach the idea, but also let them understand how this can actually apply in the real world. And also, when you have a center in your university or institute, you have a flexibility, right? So, for example, last year when we have the COVID hit, all the additive manufacturing in the world respond immediately and can actually do things, right? Like with the resources already built in the center to make different parts, such as face seal, gap, swab, has a swab, and all the different items that was left because of all the shutdown. So I do have questions I want to ask all the participants. If you have some kind of facility or center in your school or university, please do raise your hand so we can have a basic idea on like how this was it in the real world. So at the same time, I would like to invite Professor Yang to talk about the experience in Western Sydney University. So I will stop sharing. Hey, Professor Yang, maybe you can.
Yes, Alan. Yeah, hi. Yeah, I'm here. I just share my slides. And thank you very much, Alan, for this good opportunity for us to show what we're doing in the Western Sydney and on this advanced manufacturing. Can you see the screen?
Yes, we're seeing.
Okay, great. I just do the slideshow mode. Okay, yeah. Thank you very much, and a good day to everyone from all the corners from the world. And it's today myself and also Dr. Tosin Famakinwa will give this topic. So first of all, I would like to give a big picture with what we are doing at Western Sydney. So who are we here? So we look into all the aspects of the advanced manufacturing and including the additive manufacturing. That's the focus of today. So we look into the research, the fundamental research findings to help to develop the technology. And then we look into the product development and the design. So we have all the software and the hardware, and also we have a business support program. So that's what we call Western Sydney Advanced Manufacturing Initiatives, Western Sydney Advanced Manufacturing Precinct. So that's it for the hardware. And we also have the business support team, Western Sydney Launchpad program. And also we have a big network termed as the Western 4.0 cluster. So we provide the research, and the advanced manufacturing is one of the research themes in the university, and also is one of the research themes in the School of Engineering, Design and Build Environment. So we focus on the advanced engineering materials and structures, and Industry 4.0, including the IoT, AI, VR, and AR, all these popular terms. And we also look at the additive manufacturing and other manufacturing technologies. And for the lab, so we do have a very wide range of the labs available. So materials testing lab, CNC machining lab, and the nanotechnology lab, and the advanced manufacturing precinct as this focus on the additive manufacturing. We term as a 3D printing hub and maker space. So this is all open to the public. So also, of course, provide the services with a strong support from Tosin's team and to the students and the staff members. And for the Launchpad program, we provide services to look after acceleration of your business and adding in new values to your business and help you to support you and even provide a low-cost office and meeting spaces and in our building. So we also have the same focus: AI, machine learning, VR, AR, data analysis, additive manufacturing, and Industry 4.0. And so what are we offering here on advanced manufacturing at Western Sydney University? Definitely, as Alan mentioned from RIT, and we do provide the engineer education programs. So we are offering the new degrees study at Western on advanced manufacturing from next autumn semester, so 2022. So we develop and share knowledge, technologies, and services on advanced manufacturing. Also, we identify and understand the potential to partner with external organization, community, and industry, and build collaboration opportunities and a strategic partnership for the future. And also, of course, help develop new products and new business models with innovative features, especially with the Industry 4.0 advanced manufacturing, including additive manufacturing. And support all the industry partner and grow and map the future for Western Sydney manufacturing. So probably for most of you, you may not know, for Western Sydney and the government, from the state government, from federation government, they all put effort and invest the money to develop the Western Sydney as the center for advanced manufacturing. So we are right part of this movement and engineering for future. I would like to show some what's the research team we have. So currently we still term us as the Advanced Manufacturing Initiative, AMI. So I'm the leader. At the same time, I'm the discipline leader of mechanical, mechatronics, and robotics at the school, and to develop our strengths, reinforce our strengths in the advanced manufacturing. So we do have the two aims: develop and maintain the leadership and scholarship School of Engineering Design Built Environment and the Western Sydney University on Advanced Manufacturing in Greater Western Sydney region, and working with the external organization, community, and all the partners. And the second one, we would like to contribute to industry transformation and sustainable development of local manufacturing industry while adopting advanced manufacturing technologies in this area. So you can see all these the photos, images that I put here for the grand challenges for engineering and sustainable development goals from UN and advanced manufacturing brochure from the New South Wales state government, and also advanced manufacturing industry development strategies. So AM's GC as well. So you can see that all is part of our research need group's targets and aims. So we work with across the institutions within the university and act with the external partners as well. We proactively attract the fundings and work with the external organization communities pretty much, and especially look after those industries like SME, so small to medium enterprises and startup business. So that's what we do, and closely we work them right now. So currently in the Advanced Manufacturing Initiative Research Group, we have 8 research projects. So 3 funded by the Department of Defense, and 3 funded by the government and the industry, like a co-funded research projects, and also another 2 Western Sydney self-funded projects. And we have HDR projects, so 9 HDR, so 7 PhD projects, and 2 MPhil projects. And we also are looking after 35 final year student projects, and including 21 undergraduates thesis projects and 14 postgraduate thesis projects. So you can see we will accommodate, facilitate all these research activities for the to provide the service to the external organization, and also provide hands-on skill training and knowledge development, skill development for students enrolled in our degrees. So this is the 2 photos from the printers we are having, and for from Markforged. So that is Onyx Pro for the composite printing, and the Metal X for the metal printer. And also I gave 2 quick examples to show what the research we are doing. So one is for the stainless steels. So that is really focused on the design for additive manufacturing. And we work with the industry partners. And so it already maintained a relationship over 4 years. So this is the one part we designed, we redesigned the parts and available. And for the 3D printing, so the modification, you can see in the right-hand side, we did the CFD on the top. That is the original, the flow field analysis, the profile, and in the bottom, that's the revised one. So after the revised for design for additive manufacturing, and we get the better performance for this one. And in the third photo on the top, you can see that the printed parts successfully. So we are pretty much happy with that. So we are still working on the project with the industry partner, and still have the new products to look into. So try to use the additive manufacturing to replace the traditional machining, or we say subtractive technologies. And in the bottom, that's the novel nano composites research that's really focused on the fundamental research. So we have the PhD students working on the project. So we add nano additives to improve the material properties, including mechanical property, thermal property, electrical properties. So that's you also can see some testing. And I think it is my time. I just finish my part, give you the bigger picture about advanced manufacturing at Western Sydney University. Now I'm passed to Dr. Tosin Famakinwa to talk about the advanced manufacturing precinct.
Okay, thank you very much, Richard. I mean, what you've just talked about is kind of linked to why do we have these facilities. If you look at the next slide, we my teams actually support the research and development needs of the university. So that's our main goal. Then we also support the needs, of course, of the community that use our facilities. So about 6 or 7 years ago, we were thinking about how do we go with advanced manufacturing, because we can see that some universities are well ahead of us. So at that stage, we actually had a vision to focus in the process rather than at the technology level. What do we mean by that? So when we're thinking about, instead of us trying to develop the technology as a new in competition with those who have already been there for about 20 years or 15 years ourselves, we started thinking we actually should be looking at actually on the process. So let those who are developing technology be there. We can jump and start looking at the process. And by doing this, we want to acquire existing technology and start using it, looking at the process and application. That's what led us to the purchase of Markforged machine. And I will talk more about other machines that we purchased. So because as a precinct, we were looking about rapid prototyping when an industry partner is developing a new product, they want to rapidly prototype. That's why I come to 3D printing. Manufacturing of custom parts, we will show some example about that. We will look at composite technology, enhancing the material properties of this. And of course, as Richard mentioned, we use computer simulation, how this can affect material design and everything. So these are all those things that we are looking at in there. But again, our focus was more on the process. So we are not, at that level, we are not thinking of developing the technology. We want to jump on the background of existing technology or newer upcoming technology. If we look at the next slide, just it's a summary of some of those machines that we have already purchased as part of our advanced manufacturing precinct, the FDA machines, and we work with companies like Konica Minolta in some of the purchases that we have done. And then we were able to have that capability to support research and development of our university community and also those who are outside us. And when we think about it, I would just think about a famous expression that people talk about. In 1675, Sir Isaac Newton wrote in his famous statement, "If I have seen further, I have seen this by standing on the shoulders of giants." So yes, we could, as a university, start developing the technology, but it will take us longer time. So we've decided to stand on the shoulders of giants, companies like Markforged, and see more of our application on the process than others. When we look at the next slide, we talk about our 3D printing capability of Markforged. The advantage of this, I think at the end of this webinar, we'll be able to show a live demonstration. First, you have the printer itself, where it's actually print, and the Markforged has different materials, copper, H13 tools, and D2 tools. We have actually used the H13 tools a lot in our facilities there. So when you print on the first one, where the printer, and then you take it to the washer where you wash off some of the parts. I think I will take the chance away from my colleague, Raju, when we will be discussing that. And then it goes into the sintering for the final process there. It's a 3-part process, but it can work actually in an office environment. It's very clean. You can get your product. So we can concentrate not on actually on the manufacturing itself, we can concentrate on the application and on the process and how it can be used. And that's why we went for Markforged as one of our machines that we have in our facilities. If we go to the next slide, we see some other of the facilities that we use for advanced manufacturing. Again, Markforged also come out there with the composite manufacturer, CNC machine, water jet cutter, laser cutter. These are some of those things that we've got there. I would like to just show some case examples, some case study. And that one, I will go back to Richard to talk about this. It's one of our Master of Engineering project, analysis of materials from advanced manufacturing. Richard, maybe you want to just give us a brief of the project here.
Thank you, Tosin. This is the one of the examples of how we use this Markforged Metal X to make samples. So you can see that all the samples designed according to the ASTM standards. So this student is working on the microstructural analysis and the material testing for these stainless steel samples. So what the purpose is doing this is just we want to know how good is the materials are additively manufactured, and especially for the stainless steel. And in such case, we look into what's the microstructure of the printed the samples. And also we do the uniaxial tension testing and to look into what exact material properties, including those Young's modular, yielding strength, ultimate strength. So all these whole set of the properties we would like to know. So it's not only one student, so we have other students working on the similar these stainless steel related advanced manufacturing or additive manufacturing aspects. So that's really compared with the traditionally manufactured stainless steel, and to look into the best optimization of the process and to get the best materials. Thank you, Tosin, and I just pass back to you.
Yeah, thank you very much,
I move
Richard.
to the next
I think
slide.
Yeah, yes, please, the next slide. And now that's just an example of a student project. In the next slide, I want to mention some example of a case study of industry collaboration. As we have mentioned, our facilities is mainly used by students, but we have industry partners that come to us and say, can you do this for us? So I just mentioned with their permission 2 examples. Next slide, we talk about that. The first one example is a part for an overhead crane. So this part in the overhead crane, like a gantry crane, was actually manufactured by the manufacturer with nylon. So, and then they have to be replacing this part very often. So this company that actually is based in our launch pad said, and one of the engineers is our student. So knowing that we actually have the 3D metal printer, he actually suggested to his employer, why not kind of machine it by stainless steel? And they approached a number of machining house to do it. Most of the machining house gave them almost 3 weeks, and some of them didn't want to do it because, as you can see from the picture there, it's a complex shape. And to machine this, you actually need a 5-axis machine. So what the student actually came, when they got the quote for about 3 weeks at the time, 3 weeks for the lead time to machine it, he actually came to us and said, I know you have the 3D metal printer, can you do this in stainless steel? And knowing that if this part is done in stainless steel, it's going to last forever with the overhead crane. So they now replace a nylon part that needs to be replaced almost every 2-3 years with a metal printing part that we were able to do on our disc. And that's in the next place. As you can see, the finished product. On the left there on your screen, you will see, I mean, that's the way it comes out from the printer with the base that is holding the anchoring it down. Maybe one during the live demonstration, you will see more. And that's the part itself after it has been manufactured from Markforged. That's just one example. And the next example that we talk about is example of a company that actually want to do a number of parts for a mechanical shutter. And then you've got parts that are the gearbox, the gears, and other different parts. So manufacturing this as a prototype is going to cost a lot of money and time. You need to do die casting, CNC milling of the part. You can see some of the product there. Turning the gear itself, you might end up using an EDM machine. You have to grind it and polish it. So these are all complex processes to just make an assembled part of a mechanical shutter. And then, of course, you have to think about the tolerances of it, how it fits into it. It's going to, the lead time to make this is over a month for traditional manufacturing. But then when we took on this project as a university and working with a partner, we were able to do most of this parts within 2 weeks and having the extended accuracy. If you look at the next picture there, yeah. So these are all these are some of the picture of the parts as they sit on the print bed of our Markforged machines, just a build tray for the mechanical shutters. You can see how the gear and everything. And we were able to manufacture this in one shot. Although we needed to do some changes to the design, but we were able to do this to the satisfaction of the client that was making the prototype of their product. So this is just an example of some of those capabilities that we have developed because of having these advanced manufacturing facilities, including Markforged equipment in our district. All right, so I think that's all from me for now. The next part before we go ahead will be the live demonstration that we will invite our colleague, Mr. Raju Maji, that is in the lab. So you're going to look at the lab directly while on this webinar, and you'll be able to see how the process of using Markforged. So I will hand over to those in the workshop in the lab of Western Sydney University.
All right, thank you very much, Tosin. I think I pass back to Alan and I stopped the sharing, okay?
Sure, thank you both Professor Yan and Dr. Tosin. So, so if you look at the video sharing now, so here is Mr. Raju. Yeah, so yeah, Is Bob there? Okay, so Mr. Roger, maybe you can share with us like how the process start, right? Like when you have a part you want to print using metal 3D printing technology, Markforged, how do you start it, step and software you use, and then we can go to the printer and all the different steps, and so our audience like how the normal process we do. So would you like to share your screen?
Yes, yes, I will like to share my screen. Okay. First of all, good day, everyone. I'm Raju Majji, Senior Technical Officer. So basically, you need to print some parts. First, you need to import the STL part, STL file. Okay, you can import STL file example predetermined. Open file. Import STL. You got STL file now. So you need to choose the printer and material. So you got here different materials, but we need to go for this one with the stainless steel material. And we have sinter too. Then suppose you need to rotate or whatever, you can rotate by 90 degrees by using the screen example 90. So once you rotate, then also you can go to settings, what layer thickness you can select, and also you can select the units by metric or inches, and scale also you can select scales, whatever the scale, if you want bigger size, smaller size also. Then also you can go for infills, what infills you need. Also triangle, in this case we need solid infill. It will automatically come with 4 layers. Then you save the file.
So this software is basically cloud-based. So everything is happen in the cloud. So you can do a multiple part at the same time. And after finish, and you can have all this print, wash, and drying time, and material consumption as well. So back to you, Mr. Roger. So what will be the next step?
Next step, then you can see the estimated time, and also wash time, dry time, and also how much cost. Also it will give pretty quite accurate estimation to, you can advise your customer to the price and timeline also. That is great about it. And also you can see now how this print is, how it's working also. Go to the internal view. Then you can see 2D visibility, and you can see the layers, how that working on. See, first layer base, always good about this system. It will create its own base, Markforged, this software itself. Suppose example, I need to print this part, it's created. We don't need to do anything. It will automatically calculate base size and what infill required, and also between the base and to the real part, there is a ceramic layer for the release. We'll talk about the later. This everything will be predetermined by the software. That is a great about this software and this machine. So you can see now layers, how you can see how their density and supports. You can visualize everything before you go for the printing. And also you can go to 3D view also. That's good about it. Once done, what do you do? Sorry. Then go back to the part view. Then straight away, you can go for print. Then suppose I need 6 parts. I don't need to do anything simple, very beautiful stuff. Just click on here, add parts. I can add 1, 2, 3, 4, 5, 6. See, all parts ready. Now 6 parts are ready. You don't need to do anything. And then save build and export build. It's calculating print time and everything, because earlier we calculated for only 1 piece. Now it's calculating for 6 pieces. So this is, you can see here left side, 1 hour, 1 day, 10 hours material. This is 96.72 cubic centimeters cubic, and ceramic release material cost of that one also. It's give all information, means how much material we need, how much cost, how long it's taking. So then once you export build, it will automatically come to the printer. Same, already I printing here. You can see the print going on. Same parts, it's printing. Now base going on now. Then you print the real coupons. So there are 3 varieties of, in this project, 3 varieties of coupons. We're doing square, rectangle coupons, and also round bar coupons and 3-point bending. Now we're doing is round coupons. So last day we finished the rectangle coupons. Already once you print the coupons, what you do, you take to the measurements. It's a very important process. So as stainless steel, it also a very important thing, it will print also S marks here, means it says somebody may miss the what material. It's got stainless steel, that means S for stainless steel. So what do you do, once print, this is called the brown part. Then you're going to measure the weight. Measure the weight.
Hey, Watch, can we have a closer look of the part? Can you put the camera closer to the part?
Yes.
Yeah, so this is the green part, right?
Yes, green part. Yes. Then you measure the weight, very important step, never miss that one. This is number 574 grams. Then what do you take to the wash? You put wash, we go to the wash now, just a few seconds.
Can you stop the sharing the screen so we can have a larger picture of the video? Yeah, please. All right.
So now we have 74 grams after printing, after wash. Particularly, this is standard process. It's supposed to reduce 4.1% from the original value. Now we got 70.95 grams. Means suppose that is, if 71 grams, suppose example 3% wash, you should not process for this sintering. Means that there is some additives inside, means we need to rewash. But until now, I get exact size as specified by the Markforged. I used to get 4.1 to 4.15 reduction in the material weight. So next we go to this wash, how it works, and also we go to this sinter. And also I take some examples and parts there, and we talk about further. We walking through our maker space, and also we got FDM printers. There are different varieties, as Tosin and Richard's mentioned. We got, and also this is the large printer, and we got also our laser cutting 5 mill, and then we have, this is a wash. Before go to wash, we need to talk about a bit of safety, and always very important to do this one. Then they're not like other powder bed machines, but still always we have to follow the safety stuff. You need to wear the mask because when you go into the chemicals, and also you wear the glasses, and also I wear the face cream. This is made by us. And also we have chemical stand blouses, and go to the wash. We have wash here. Come with the stainless steel tray. And what do you do? Yeah. Which one the parts we need to wash? We put inside. And after one, very carefully. Sorry for that, I need to use a mask here. This fumes of this was may harm the people. So once you've done that, so there is a liquid there inside. There's a fumes. It will automatically depend on the what volume of the material. Now I can remove my stuff. So depend on the volume, it will give a time automatically. Markforged give a predetermined time how long it will take. Then also like what I said before, it should reduce 4.1%. Depend on the material. Every material has a different percent advised with the Markforged. Like a H13 may be different, 0.45 maybe different. So once your weight is, this part is washed, then you go to the dry. There is a dry chamber here. There's no harm. And also it's fan there. Any fumes also it will exhaust outside. You can see the exhaust system, and you dry it out for 4 hours. Then you measure the weight. If everything is okay, we come back to the sinter. Sinter is this is sinter 2. This is the first one in the Australia as a moment, but trouble free. Day one, we got best part from first day onwards. So here we have 2 gases. One is mixed gases, mixture with argon, hydrogen gas, and then is argon gas. That is for the shield gas. This is a backup gas, and also we have I will show the we have also 12-pack gas here. That is the gas for the sintering. Sometimes sintering depend on the low load take 20 hours, but generally full load 30 hours of time. So sinter, how it works, you need to, as for the label here, we need to adjust the gas pressures, everything. And also it's got very good thing. It will predetermine how much gas required. It will communicate with through internet. It will communicate to the system. Yes, this is a required gas. This is the available the gas, and it will avoid like a sintering failure. Suppose half the way sinter failure, that is the cost, but this already predetermined everything. It's such a beautiful system. And also to maybe error, maybe some leaks already you have here also standby gases. That is one more advantage of here. So sinter, how you do sinter here? Here when you're doing sintering, you need to wear once again come to the PPE, you need to wear now you don't need full parts, but still better reason wear. And this is sinter door. You open here, what are the parts? We fill here, we got only low volume parts. You can fill the parts inside. And very important, don't touch any of them, each other, don't touch to the body. And also it's give particular, the depend on the weight also. What you selection, suppose this one low, example, I'm not going to do this for demonstration purpose, but it's like a 20 hours process. If full, it's like a 30 hours process. Once you push inside this one, and we have also here safety lock system, and it locks automatically, and also if you have a proper locking mechanism, then you can start sinter. Once sinter done, it will like 30 hours. It will give you all chart here, which is from the how to go, how it's go through the process. Every information you can see from the your eager software. Once done, next day you can see the cool down automatically. It will give you once cool down only it's open. This is a special lock. You can't open anything. It's so safe system. So it's got some locking arrangement. Once sinter done only it will be able to open. Anybody can touch, it's not. You can't open. So then once done sinter, for example, this is different part. Example, I finish the sinter. Example, I bring, this is the base. This is the part. So it's come where we talk about there, this stainless part. In between we talk about ceramic layer. That ceramic layer will be become after a particular stage, it will become like a powder, and you take to the vise with just with plastic hammer, you hammer the base part, this real part will come out from that. How beautiful it is. If you go to the like a powder bed manufacturing, you need to use a wire iridium, whole plate, and you need to cost also involved, time also involved. Here, no problem, you can get. Then once in the, you compare there, you need to remove, once remove from there, you need to machine by CNC machining the all supports. In this case, you don't need to do anything. You just bring it here. Then we also have vibration chamber, post-processing system. We vibration chamber, we put it there, we make polish. So then also we see impellers, how great it is. You can see how details. And this is a still base there with this. This base, if I knock, I keep this purposely. And if knock, you can, it will come out easily. Then you can use the directly part, what you need purpose. So another part, this is the H13, H13 tool steel. I am come from the actually traditional manufacturing since for 20 years. To make this one, you'll have a lot of trouble because H13, they are high strength, low ductility. When you machining, they will warp like this. Then once you machine, you need to keep some of the stock like a 0.3, 0.3 or 0.5, 0.5. Then you need to go for heat treatment. During the heat treatment, it will warp once again. And you need to grind that. So much process. See here, so beautiful, 3.2 mm H13 plate for the maybe looks like some, I don't know, because customer, they don't disclose for what purpose. We don't ask also sometime, but we'll ask them for if that is part is, if it's not for the application, you know, something else. So this part is printed, and this is the base, this is the part. Parallelity within 0.05, 50 microns. You can't get in the traditional manufacturing straight away. You got from the Markforged perfectly. And if traditional manufacturing, after heat treatment, you need to grind, and you need to also remove rust relieving and polishing. Here, just you can go, suppose if they need a bit of very fine finish, we need to go for grinding, and you get the like a 0.2, 0.3 microns of finish. Now it's come like a 4 or 5 microns finish. Depending on the what layer selection you did, angle and everything, that's finished. So from me.
Very good.
Thank you.
Thank you, Raju. Hi, I'm Bob Bentley from Konica Minolta. Konica Minolta are actually the national distributor for Markforged here in Australia, and we work very closely and very proudly with Western Sydney University. Just had 3 questions before we let Raju go, and thank you for the whole demonstration, Raju. I really appreciate it. Do the students, your actual students, have access to the Markforged Metal X?
Yes, of course. This is for them. We are university.
Right.
We
Yeah, good. What is the benefit then of that hands-on experience for the students?
Of course, this is they are engineers. They need to know the process. Which process can be done easily. Suppose if this part they go by traditional manufacturing, if they don't know, like example, Tosin talk about that crane hook, because that engineer knows we got metal printer, and
Right.
he come to us. That's the reason we give our student to access this place.
Right.
And also we follow. We don't access like that. We give a training. We got risk assessment process. We got systematic training process. We give them training, and also we buddy them how they are working on. Once they are okay with that, we'll provide them full access.
So massive benefit. And
I would like to jump on that.
Hands-on experience, not with just a smaller plastic machines, but having hands-on experience for our future engineers.
Yes, definitely.
To have access to a full metal printer.
Yes, definitely. But see, they can test their model on the plastic printers. That's very cheaper. Once they are happy, they can come to the metal printing. They can see themselves how it's working, and they can put their hands and work with us.
Yes.
And they know process, and it's a huge benefit for everyone.
Excellent. And Tosin and Richard mentioned that you work a lot with industry, and they showed us some of the examples. Are you encouraging industry from around the western suburbs, but also across Sydney? Are you encouraging to come here and to have a look at the processes and to work with them? Is that the idea?
Yeah, 100%. Without industry, we are always university develop R&D, but industry is the backbone for all of us.
Yes.
Without industry, we are not surviving. We give them high priority also, but our students comes to us first priority, but still industry, we encourage the industry, hire our students, work with the projects.
Yeah.
We first priority industry collaboration with university, with students, then they will be employable. That's our idea is that. That's the good benefit for the students and as well as industry.
Very good. Well, Raju, thank you once again for doing the demonstration today.
My pleasure.
Very much appreciate it.
Yes, thank you very much. My pleasure to do this.
Thank you. And back to you, Alan.
Thank you, Raji. It's a very detailed, very good demonstration. Facility looks amazing. Everything is very clean, and the part looks great. So, all right. So let me share my screen. Okay. So looks like we have more than what we can share. We have more than the time we have. So so now we will answer some questions.
Everybody, you guys can understand. Everybody
can
understand.
Yeah, absolutely. It's fine.
Yeah. So yeah. So that's a lot of questions. Probably we won't be able to answer all of them. But definitely we will answer a few. So that's a question about how to compare the metal printing technology to conventional manufacturing technique, right? So I think metal 3D printing is not try to replace the conventional technology. It's just about for one job, which one do better, right? So the 3D printing would be better in doing more complex geometry, which traditionally maybe require a couple of different processes to compete. And also 3D printing is good for like small or medium volume, rather than like conventional manufacturing may be very good to doing one thing for many times, like hundreds of thousands times, right? But that maybe conventional manufacturing is better. But 3D printing would be very good for complex geometries, special part, small, medium volume. production, and a special design that might not be able to manufacture with a conventional manufacturing process. Oh, I see Professor Yang has helped answer a lot of a question already. So there's a question about, just look it quickly. Just one question for Professor Yang is like, do you see any industrial partner that talking to you also require saying, hey, we want to have a graduate have more experience in additive manufacturing or with more hands-on experience in additive manufacturing?
Well, I can jump into that, Alan, if it's okay.
Absolutely.
Yeah, go ahead.
Definitely. We've got a lot, many of our partners, like the company we did mention recently, because our student was employed, and knowing that the student have the skill set of advanced manufacturing experience, we've had a number of companies actually taking our students on industrial experience and keeping them. Not only one, and I can mention about a couple of them that I know. After they come, they said, look, your students have this experience, they've run this equipment, they know how to design for 3D printing for advanced manufacturing. We want those students to come to our company and work for us.
Great, that's great. So there's a question also about like, you have so many equipment, not just Markforged, of course, including Markforged. And does it increase the engagement of students? Do they find it more fun to actually work with a machine and making real part for their projects?
Yep, probably I can answer this question. Of course, yes, because in the university engineer education, we definitely would like to have the student to tackle the latest advances in technologies, especially for mechanical, robotic, mechatronics. We want the student can have a good hands-on skill development. I think this is one of the uniqueness we are having in this Western Sydney University. And the students are definitely, they are very keen to do the such skills development. And that is why we have 35 research projects for the students to do their final year thesis work in this advanced manufacturing precinct. And this is the one benefit. And also for the student to don't misunderstand us, we also have the traditional manufacturing equipment, and we still deliver those material removal processes, including the turning, milling, drilling, all these manufacturing technologies. So we provide both to the student and let the student to taste it and let them feel and what the future would be and what the future technology can help them. And from already Tosin mentioned that, so we do have the local manufacturing sector needs, and they want the students graduate the future, the engineers have those advanced manufacturing skills. And that's really fit into the needs manufacturing back to country and also supported greatly by the government. So that's the all good trends we are having. So that's why we developed the Bachelor of Engineering degrees and for the advanced manufacturing. So we want to have this one formally provide formal training to the student and get them ready for future. So that's what we say, engineering for future. Thank you, Alan. I hope I answered the question.
Sure, absolutely you have. So we are running a little bit over already, so maybe probably the last questions. This question about like, so you have so many different technology. So why you choose Markforged, and what is special or unique about Markforged technology for you to utilize it in all your project and teaching?
Thank you, Alan. That's a really good question. And we work with Markforged quite well, and we appreciate their great support, provide technical support all the way. And we also relying on to their the high quality equipment and to do the teaching and learning and to do the research. And that's what we already show, slides. And also you can see Raju show around what's the equipment we are using and from Markforged and how good they are. So you can see the quality of the additively manufactured parts, metals, and also we actually have the composite samples as well. So they are all at very good quality, greatly promote our research and learning and teaching, and reinforce our strengths in this advanced manufacturing area. So we definitely greatly appreciate it. I believe this good relationship will last much longer, and we'll carefully cherish this relationship. And thank you, Markforged.
Oh, thank you very much.
If I may just echo the same words of Richard. One of the good things about Markforged, someone who look after the facility, like you don't want to spend time fixing the technology because then you need to employ so many people. Markforged equipment are so reliable. We want to focus on the application rather than just fiddling with the machines all the time, that we don't have time. So, and this technology has been so reliable with us to use, and we really appreciate the relationship. Konica Minolta has been very good distributor. We've been working with them for a number of years, and having the Markforged to our family has been really very good. And the students can focus on what is more important. There are students who need to focus on technology development. Those are different group of students. But our students, when they're working on R&D, they look more at the application, and they need to focus more on that. And that's what we see. That's our vision when we purchase Markforged.
Thank you very much, Dr. Tosin, as well. Thanks for all the nice work. So we are already 8 minutes overrun, so I guess we have the end here. Thank you very much both, and thank you everyone for joining today's webinar. Someone asked about getting the material that we share, so we will have the recording shared to all of you in a couple of days. So look after your emails, so we'll email to you. Thank you very much, everyone. Have a nice day for the rest of the day, and we will see you again. Thank you.